Okay, coming back to our final chapter that we're going to be going over, this is going to be looking at a different style of programming, looking at functional block programming. So hopefully as a result of going through this material, you'll get a perspective on yet another approach that you might encounter. So a functional block diagram is a graphical depiction of process flow using simple and complex interconnecting blocks. And so here we're seeing some examples of what that might look like in a simple form. It is similar to a ladder logic diagram, except that function blocks replace the interconnections of the contacts and the coils. In addition, there are no power rails. Functional block circuit is analogous to electrical circuit, where limits and wires depict signal paths between components. The workspace is known as a sheet, and it consists of function blocks joined together with lines called wires. Function block program or routine consists of functional blocks, references, wire connectors, and wires. So a line type of a link between functions indicates what type of data are present. So a solid line indicates an integer or real value. A dashed line indicates a Boolean signal path of a 0 or a 1. So there are graphical representations of executable code. A functional block can take on one or more inputs and make decisions or calculations and then generate one or more outputs. There are many different types of function blocks included in the programming software to perform various common tasks. Customized add-on instructions can be created by the programmer for sets of commonly used logic. Here is a band, Boolean, and function block to give you an illustration. References represent tags that are linked to values stored in the control's memory. An input reference or IREF is used to receive a value from the input or device or tag. An output reference or OREF is used to send a value to an output device or tag. When you use an IREF or an OREF, you must create a tag or assign existing tags to the element. Keep that in mind. Function blocks can be connected to other function blocks by connecting their outputs to the input of another block using the wires and pins. The pins on the left of a function block are input pins, and those on the right are the outputs. So keep aware of that kind of a configuration. Elements are connected by moving wires from input pins to output pins or vice versa. To wire two elements together, click the output pin of the first element A and then click the input pin of the other element B. A red dot shows a valid connection point. So wire connectors are used to create a path without using a wire. When there are many function blocks on a sheet or a function block are far apart, wire connectors used in place of wires can make the logic easier to read. So keep that in mind. Wire connectors are also used to connect function blocks that are on a different sheet of the same function block routine. So an output wire connector or OCON sends a value or signal to an input wire or connector or ICON. Each output wire connector must have at least one corresponding input wire connection. Each output wire connector requires a unique tag name, and the corresponding input connector must have the same name. Multiple input wire connectors can reference the same output wire connector. Here we see signal flow and execution of a FBD program. So now you're starting to see the things that we've mentioned so far in more detail, and giving you an example. Data latching refers to how the controller verifies that the data present at the input to the functional block are valid. You use an IREF to specify input data for a function. That data in that IREF or latch for the scan of the function block routine. The IREF latches data from program scoped and controller scoped tags. The controller updates all IREF data at the beginning of each scan. A function block routine executes in the following order. The controller latches all data. The controller executes the other functions blocks in order, and the controller writes outputs. So those are things that you'll want to be mindful of. A function block instruction first appears with a set of pins for a default parameter, and the rest of the pins are hidden. Here are just the parameter tab. If you were actually to be playing with the actual software, you can click on the programming tab in the properties dialog box. On the parameters tab, clear the viz check to the hidden pin, select the viz checks into the box showing the pin. These are all kind of things that are available. You can create a feedback loop around a block, wire an output pin to the block of an input pin of the same block. That's possible. There may be times that you want to be having that function. When a group of function blocks are in a feedback loop, the controller cannot determine which block to execute first. This problem is resolved by placing an assumed data available indicator mark at the input pin of the function block that should be executed first. In terms of FDD programming, the setup procedure for FDD program, right-click on the main program file and select New Routine from the pop-up menu. Select the function block type from the type window, enter a name, and then left-click on the FD_sample twice, opens a graphic development window. So we're talking about a specific tool as well as just giving an introduction to FDD programming. Here are the toolbars, similar to what we've seen before, but now for this application, the FBD instruction selects from the language element toolbar are used in the development of the program. Extra sheets can be added when the current sheet is full by clicking the Add Sheet icon. Movement between sheets is provided by left and right arrows. The main routine and subroutine. The main routine is always a ladder logic program in RSL Logic 5000 software, and all other routines are called from the main routine. The main routine will have one unconditional rung and a jump to subroutine calling sample FBD_sample. The FBD program will execute from the JSR instruction. No subroutine or return subroutine instruction in the FBD is necessary. You can make a comparison between the ladder logic and the FBD equivalent for 3 inputs and output ladder logics. And so now you're getting the chance to compare them one to another. You compare between ladder logic or FBD equivalent for a 2-input or ladder logic rung that's shown below to give you a perspective, and compare between a ladder logic and an FBD equivalent for a combination of multiple inputs. So here's a comparison between the ladder logic and the FBD equivalent for a motor start/stop control circuit, and comparison between a ladder logic and an FBD equivalent for a 10-second TONR timer, things that we've talked about in previous chapters. Comparison between the ladder logic and the FBD equivalent for an up-down counter application. And here we have a comparison between the ladder logic and the FBD equivalent for a program used to test the accumulated value of a counter. And then finally, we have a comparison between the ladder logic and the FBD equivalent for a program used to test the accumulated value of a counter. So that's just a quick introduction to FBD programming, just to give you a complement to what we've done with everything else we've covered in our class. Thank you very much.